In lesson 4-6 on page 182 in our math journals, we are going to talk about the distributive property. So when I distribute something, I hand something out. So if we look at each of these problems, we are looking to find the area of each of these rectangles. Each of the expressions below represents the area of rectangle N, O, or P. Record the letter of the rectangle that corresponds to each expression. So before we go ahead and look at part B, let's actually go back up to A and let's figure out what the units are so we can then figure out which expression goes with each of these. So in order to find area, I know that I take the length times the width, or sometimes we use the general pattern base times height. And again, remember, I can use different variables. They represent the same thing. Sometimes I put a time sign in there. Sometimes I can put them right next to each other. So my base is going to be right here, which happens to be 7, times my height. Now, it doesn't actually specifically tell me my height, but I know that this part here is 3, and this part is 2. So I can take that 3 and that 2 and put it together right here to get 5. So 7 times 5 gives me 35. Go ahead and do the other two and then pause your video. We'll come back and check them. Okay, you should have looked at the bottom here and saw that 2 plus 7 gives me 9 times my height, which is 3, which gives me a total of 27. And for the last one, my base is 3 plus 7, which is 10, times my height, which is 2. 10 times 2 gives me 20. So what we needed to do now is look at each of these expressions to figure out which ones match up and are equal to each of these rectangles. So I can look here and I can see that 2 times 3 is 6, and I can see that 7 times 3 is 21. And when I add 6 plus 21 together, I get a total of 27. Which one of my rectangles was 27 square units? Well, that would have been my middle one there. That would have been rectangle O. If I look at my next one, 2 times 3 is 6, and 2 times 7 is 14. When I add those two together, I get 20. So that has to be rectangle P. And finally, my last one, I get 14 and 21, which adds together the 35. That has to be rectangle N. If I come over here to the other side and I check and I use order of operations, 2 times 7 is 9, 3 times 9 is 27, which is my center rectangle O. I add here in parentheses and multiply, I get 20. And my last one I add together to get 5, and 7 times 5 is 35, which is rectangle N. You are going to notice and see that each of these match up. Okay, and the reason how we got each of these was exactly what we did up here. So if you look at O, for example, when I take O here, they took the one side, 3, here it is, times my other side, we added, see how we added 2 plus 7 together to get 9? Now we took 3 times 9, but we got this 9 by adding 2 plus 7 times 3. There it is. For my next one, for P, we had to take the base, which was 3 plus 7. See how we did that here? Times the height, which is 2. Now, we just happened to combine them and get 10, and then multiply that times 2, but it was exactly what we did down here. And same thing for the last one. Now, when we come over here and look what they did. They simply took this 3, and they took the 3 times the 2. So this 3 times the 2 gives me that part. And the 3, so remember, this side here is 3, this is 3, and this is 3 because they all match up, right? So they could take 3, and this part was 7, and multiply that together, and then take each of these parts here and combine them. Here's what it looks like when we actually write it out. We took the 3 times the 2, which you can see 3 times 2, which is over here, that. And the 3 times the 7, which we hand out, and it becomes this. We call that distribution. The same thing happened with the other two rectangles. We took the 2 times the 3, which you can see right here, and it's written out over here. And then the 2 has to get multiplied times the 7 for this other part. 2 times the 7 right here. And we can take those parts and put them back together. So if we look at number 2 on page 182, it says write 2 equations to represent the area of, or the area, of rectangle B. So if I look here, the one side, the bottom side is going to be 6. Let me write that. My height is 4 and 5. So we could write that it's 9. We also could write it as 4 plus 5, which is 9, right? In this case, they want us to leave it as the expression, the sum. So when I come over here, I'm going to take my 6, which is my 1 unit, times my height, which is 4 plus 5. And we know that 4 plus 5 is 9. So naturally in our heads, we want to take that and make it 9. 9 times 6 is 54. However, in order to show distribution, we're going to leave it like this. Now, I could look at it separately as each individual rectangle. So I can take this 6 times the 4, and that's going to give me this part of the rectangle. And then I could take this 6 times the 5. And that'll give me this part of the rectangle. And then in order to get the entire rectangle, I'm going to take and combine those, which I did right here with my plus sign. And when I do that, I get the bottom part is 20. The top part is, just kidding, 24. Sorry. The top part is 30. And when I combine those two numbers, I get 54, which is the same thing up above. So there's lots of different ways I can attack this problem to get the answer. Both ways work. Let's look at the next question. Now they're telling us what the area is. We need to figure out how much x is. So instead of saying that the base is a certain number and the height is a certain number, and we're going to take those two numbers and multiply them together to figure out what they equal, they're telling us that the area is 144. So do you see why they already filled in the A? So this is the base times the height equals area. We know what area is, so they filled it in. Let's see what else we can figure out here. And actually, we're going to have to reverse these just so that it makes a little bit of sense. So let me change. Oops, why is this not erasing? There we go. Sorry, I was having some technical difficulties here. Let's call this the height and this the base, because if not, it's not going to make sense. In a minute, you'll see. So my base, this part is 6, and this part is x. So we don't actually know how much my base is yet, but I can rewrite it as 6 plus x, because we don't know what our x is. Here's my height, which is 12, so I can fill that in. And we already know my area is 144. So let's take my base and let's fill it in. It's 6 plus x, which we already have my plus x there, times my height, which is 12. Now, some of you can look at this point and say, ooh, I know that 12 times 12 gives me 144, and you can solve it that way. You're absolutely correct. You could do that. However, I'm going to show you distribution, because eventually when we get into algebra, you're going to need to know how to do this. So if I go over here to my picture and I look at this, I could find this part right here by taking 12 times 6, right? Which looks like this when I write it out as an equation. 12 times 6. And then I could find my other part over here by taking the 12 times the x. So I'm going to come here, and I'm going to take the 12 times the x. So instead of looking at it as as the base and the height and multiplying them together, I can look at them as two separate rectangles. Now, if I come down here and simplify it, they didn't really give me a ton of room. I know that 12 times 6 is 72. And 12 times x I can rewrite as 12x. And I bring down this plus sign here, equals 144. Here's what algebra looks like. I'm going to get rid of this 72 and subtract and get 72, and this cancels out. 12x equals 72. 12 times what number gives me 72? Well, I could use the inverse and divide. Remember those hearts I have up in the front of my classroom? Multiplication and division go together. 72 divided by 12 gives me an answer of 6. Okay, now I know that you can look at that. We didn't know that it was split in half. It looked like it, but we weren't sure. But now when we go back, if this is 6 plus 6, the whole side equals 12, and 12 times 12 does give me 144. So ladies and gentlemen, what we're looking at here, okay, is that we want to write out the one side and the other side, okay, but we want to write them out as exactly as they're written. So like up here, this was 5 plus 4. Yes, I know you know that's 9, but we want to write it out exactly as it is to demonstrate the distributive property. If we continue on the next page, is page 183, we're going to see some similar problems, except this time some of them are shaded in. So let's look at some of these. What is the area of the shaded part of rectangle G? So we want to know just this section right here. We don't care about the whole rectangle. So we can figure this out by finding the base and the height. So we want to know the base just right here. Well, we have a problem. Up here and up here, bottom and top, it doesn't tell us how much it is. However, I have noticed that from here to here is 10, and this part is 7. So if this is 7, that means that this part from here to here has to be 7, right? And if the entire thing is 10, I can take this 10, the whole length 10, take away this part 7 here and figure out what's left. So I can write my base by saying 10 minus 7, which you know is 3, but we're going to write it as a subtraction problem right now so that I can show you how distribution works. So this part has to be 3, again, because this whole side here has to be 10, because it says 10 up here. So 7 and 3 more makes 10, or 10, take away the 7 gives me 3. So we're going to write it as a subtraction problem. And then I'm going to take my base times my height. My height is 5. So let's go ahead and write this out. We're going to take my one measurement. We're going to take my height. We're going to put 5 in here. We're going to multiply that times the base. So this whole thing here is the base. The base is 10 minus 7, which I know you know is 3, but we're going to write it as a subtraction problem. Now, what I could do is I can also hand this 5 out. Anytime we have a number here that's being multiplied by parentheses, I can take and hand those out individually instead of handing them out to this entire thing. So we can look at this entire problem here and see that if I take 10 times 5, this entire thing is 50, right? And then I could subtract this part away and take the 5 times the 7, which is 35, and I could subtract them to figure out what's left. Here's what it looks like over here. I'm going to take the 5 times the 10, which we did right here, and we got 50. I could take the 5 times the 7, which we did right here, to figure out this part right here. So I handed the 5 to the 10, the 5 to the 7, and I got 35. And then when I bring down my subtraction sign, so before we did addition, now we're doing subtraction. When I bring that subtraction sign down, 50 minus 35 gives me 15. And we already figured out this was 3 because we subtracted, and this was 5. 5 times 3 is 15. Let's look at the next problem, problem 5. We want to find the area of the shaded part again. So to find the area of the shaded part, I'm going to figure out what my base is. My base is 8. And I'm going to figure out my height from here to here. In order to figure that out, I have to take this entire thing, which is 12, and we don't want this piece right here. So I'm going to rewrite that as 12 minus 3. So my base is 8, and 12 minus 3, which I know you guys know is 9. Okay, so then when I take 8 times this becomes 9, 8 times 9 is 72. Now, if we were to do distribution, because remember, we can take this guy outside the parentheses, we can hand it out to the parts inside. We can write 8 times 12, and when I do 8 times 12, I get 96. This tells me 8 times 12, the area of the entire rectangle. Problem is, we don't want this piece right here, so I have to take 8 times 3, which I can get by multiplying here, and I get 24. I'm going to subtract that unshaded part out. When I take 96 minus 24, I still get my answer of 72. Moving down to the last problem, the area of the shaded part is 30. So they happen to tell me what the area was. So see how I put it down in here in my equation? The area is 30. Let's see if we can figure out how we can get y, because it looks like we have a y embedded in our problem. My base is right here, because remember, I just want the shaded part. How do I get this measurement? Well, I have to look up here, and I see that this entire thing is 8, and I don't want this piece right here. So the whole thing is 8. Take away this part right here, which is 3, and I can get my base by taking 8 minus 3, which I know you know is 5. My height is right here or right here, which we don't have a measurement, but I can happen to look over here and see that it is y. So my height is y. So essentially what I'm doing is I'm taking my 8 minus 3, which is 5, times y. So 5 times y is what's going to give me my area of 30. Now, if we come back over here to my equations, we said the one side was 5 because we took 8 minus 3 times y, which is my height, gives me 30. We can hand this y out to each of the numbers. 8 times y and 3 times y, and I can rewrite that. And again, 8y and 3y is the same thing, and I can subtract. When they both have variables in them, I can subtract both of them. That's 5y. 5 times what number gives me 30? Well, 5 times 6 gives me 30. We can use the distributive property with subtraction and addition. You simply take whatever operation is here, whether it's subtraction or addition, and you simply, as you distribute, you simply move that sign down. Here's what it looks like without rectangles. Okay. The rectangles are certainly helpful for helping us to see it, but for some of us, it actually makes things a little bit more confusing. So let's practice some problems without having the rectangles. Here is my problem. Now, typically, we would use order of operations, and we would say, I know that 3 plus 7 is 10. 4 times 10 is 40. Bam, I'm done, Mrs. Myers. But we're practicing the distributive property. So let's hand the 4 out. I'm going to hand the 4 out times 3. And I'm going to make 4 groups of 7. So I'm going to make those groups separately. And then I combine them together. 12 plus 28 still gives me my 40. I just attacked the problem a different way. Let's look at the next one. I can take the 9 and hand it out to the 6. And I can take the 9 and hand it out to the 3. You're going, well, Mrs. Myers, I knew that 3 taken away from 6. So 6 minus 3 is 3. And 3 times 9, because this is multiplication, it's right next to my parentheses. So 3 times 9, I know that's 27. You're right, it is. Okay, however, let's look at it and see that 9 times 6 is 54. 9 times 3 is 27. And when I subtract, I still get my answer of 27. Now it gets a little bit more complicated. We put a variable in here. So I can't add x plus 4. I don't know how much x equals. So these are the specific situations where we have to use a distributive property. Here, we didn't really need to. We could have used order of operations. This one we have to because there's actually a variable in there. I can't add 4 to an unknown number. So because I can't do that, I have to take this 7 that's outside my parentheses and I have to hand it out. So I'm going to hand it out to the I remember I always work left to right in math. So I'm going to go to the very first term in my parentheses. I hand the 7 out to the x first. I don't go straight to the 4. I have to go to the x. Then I'm going to take the 7 times the 4. And I can rewrite 7 times x as 7x plus I could take 7 times 4 and get 28. So ladies and gents, this expression right here is equal to this expression right here, which is equal to this expression right here. We call that simplifying. So I want to get rid of parentheses just like I do in order of operations with PEMDAS. I want to get rid of my parentheses, and I do that by distributing and rewriting my problem. And now you see that I have an expression that doesn't have parentheses in it. It's still equivalent to what I started with. It just looks different. Kind of like I can say 7 is equal to 4 plus 3, or it's equal to 5 plus 2. They both have the same value, they just look different. Let's continue. I'm handing out the 5. 5 times 9, so I'm going to fill that in. 5 times 3 is 15. And then I can simplify. 9 times 5 is 45. 5 times 3 is 15. I subtract, I get 30. This expression here is equal to 30. Let's skip down to a few other problems. Let's look at problem 6. I see my 3. Now I certainly could add 4 plus 2, but I'm going to hand my 3 out. 3 times 4. And 3 times 2. And in between them, I see this plus sign, so I have to bring my plus sign over. 3 times 4 is 12. 3 times 2 is 6. When I add those together, I get 18. Let's skip down here to problem 8, because I think sometimes when we do problems that don't have a variable in them, it's kind of like, well, why would you do that? Because Mrs. Myers, I can add this and get 6, and 6 times 3 is 18, and I can skip all this work. I get it, guys. So let's skip down here to some of the ones that have the variable. If I don't know the value of x, I can't subtract 4 from it. So let's hand the 2 out. 2 times x. And let's hand the 2 out to 4. And in the middle of them, I have a subtraction sign, so I have to transfer that over. I can rewrite my problem by taking 2 times x is 2x. And I can simplify this part, because remember, I always do multiplication before I do my subtraction. So I'm going to write this as 8, and I'm going to bring my subtraction sign over. And then I can't take a term that has an x in it and one that doesn't have an x and combine that. It's illegal. So my new expression, that expression there, is equal to 2x minus 8. It just looks different. Let's try one more. I'm going to hand out my 7. Remember, I take that 7 to the first term behind my parentheses. I don't start with a 5. I go to the y. So I'm going to multiply 7 times y. And then I'm going to hand it out to the 5. 7 times 5. And it looks like there's a plus sign in the middle, so I have to move that over. 7 times y is 7y. 7 times 5 is 35. And here's my plus sign, so I bring it over. This expression here is equal or the same value as this expression. It just looks different.